Hey, AP Chemisters, this is Mrs. Vanderlei bringing you section 3.10, part 2. This is the section that you really got to think about what's going on. You really need to visualize what's going on. This is a continuation of the empirical idea, but we're going to get our results from an actual lab, all right, a combustion analysis. So what's going to happen here is we're going to take our hydrocarbon sample and we put it in a furnace, okay? And we're going to burn it. We're going to burn it with some oxygen, okay? And what do you make? So anytime you have a combustion, we learned this in first year chemistry, a hydrocarbon plus oxygen will always make water and carbon dioxide, okay? Always. It's your combustion reaction. So what we're going to do is that we're going to analyze the amount of water and analyze the amount of carbon dioxide that we're creating from this combustion reaction. And what we realize is that all the water that we produce, the hydrogens come from the hydrocarbon. And all the carbon dioxide that we produce, all the carbon comes from the hydrocarbon. These oxygens we're not going to really worry too much about because they come from this oxygen or the oxygen that we put into the furnace. So the analysis, if we can figure out how much water we make, how many grams of water we make, we can find grams of hydrogen. And then you can do the empirical RAP formula to find out moles of hydrogen. From here, we can analyze how many grams of carbon dioxide we get to how many grams of carbon we get. And from there, we can use the empirical formula RAP to find out how many moles of carbon we have, divide by smalls to get the whole, okay? So as I wrote here, all moles of the hydrogen and water come from the hydrocarbon. Note there are 2 moles of hydrogen. All moles of carbon and carbon dioxide come from the hydrocarbon, and proceed finding the empirical formula, just like the RAP, okay? So it says, upon combustion, a compound containing only carbon and hydrogen, this is the easy one, produces 1.83 grams of carbon dioxide and 0.901 grams of water. Find the empirical formula. Okay, let's do that. So what do we know here? We have 1.83 grams of carbon dioxide. What is it that I'm looking for? I'm looking for moles of carbon. So can I factor label to go from grams of carbon dioxide to moles of carbon? Well, of course I can. All right, so now what? I'm going to, well, what has to go on the bottom, everyone? Yeah, that's right. Grams of carbon dioxide. So there it is. But wait a minute, do I want moles of carbon dioxide? Because that's on top. No, I don't. I want moles of carbon dioxide on the bottom to put moles of carbon on top. So I want moles of carbon to do the empirical formula thingy, right? So what do I get here? Divide times 1, and I get 0.0416 moles of carbon. So I got to do the same thing with hydrogen. How many moles of hydrogen? Because that's what I need to find, the smallest whole number ratio, don't I? Well, what goes next? Do I want grams of water? Of course not. So I have to get rid of it. I'm going to put it on the bottom. What's the only thing grams goes to? Moles of water. But I don't want moles of water. I want moles of hydrogen. So this is a really important step right here, right here, right here. So for every 1 mole of water, you get 2 moles of hydrogen. Up here, 1 mole of carbon dioxide. Why only 1 mole of carbon? Because that's my subscript. So when I do the math, take this, divide by this, times it. And if you look at the math, oopsie, sorry about that. That looks pretty nice, doesn't it? Okay. So what would VV mole V tell you to do? I got 2 moles. I got moles of carbon, moles of hydrogen. So what's my next step? Divide by the smallest. Well, which is my smaller number? Hopefully 0.0416. Whoops, that's not what I wanted to show you. Here we go. And so I think the first one's pretty easy. And the next one is, stop that, is right, nope, there it is. And what number can you multiply 2.4 by to get a whole number? It's 5. All right, did that make sense to you? So if I multiply by 5, okay, I'm going to get 5 here and 12. So what is my hydrocarbon? C5, oops, H12, which is indeed pentane. So that makes sense. As a chemist here, I know C5H12 exists, all right? It's the empirical formula, and it ends up being the molecular formula. So why don't you try problem number 28 all by yourself, okay? Follow the exact same steps, okay? You want to get moles of carbon, you want to get moles of hydrogen from this data. So factor label and get moles of carbon and moles of hydrogen. So pause this, look at what I did up here, and make sure you can do it yourself, okay? So see you soon. All right, let's see how you did. Well, what goes on the bottom here? I'm going to scroll this up a little bit. What goes on the bottom? Grams of carbon dioxide. Grams, periodic table. All right, and then what? I don't want moles of carbon dioxide. What is it I want? I want moles of carbon. So I'm going to put that right here. Notice the moles of carbon dioxide cancel out, moles of carbon's on top. So now if I go ahead and do my math, what do I get? I got this, 0.0364 moles of carbon. Do the same thing with water. So I don't want water, I want hydrogen. So I got to get rid of the grams of hydrogen, or excuse me, grams of water, put moles of water on top. And this is the important step. Don't forget this. For every 1 mole of water, how many moles of hydrogen? Look at the formula. For every 1 mole of water, you get 2 moles of hydrogen. And so what do you get when you divide and multiply? I got this. So what would VB mol V tell you to do at this point? Divide by the smallest. Divide by the smallest to get the whole. So this is a 1. But if I divide that out, this is a 2.5. So what are you going to multiply both 1 and 2.5 by? 2. And you're going to get a 2 here and a 5 here. So what is my empirical formula? C2H5. Okay. All right. Hopefully you had success there. Now we're going to add a little twist to this. Let's go to the next page. So the twist is if the hydrocarbon contains oxygen. We got to work a little bit harder to figure out what the empirical formula is. So we're going to need the original mass of the compound. We didn't need it if it's just a hydrocarbon. We need it for the oxygen. So this little oval represents the entire mass. What we're going to find is we're going to calculate the grams of carbon, the grams of hydrogen, and subtract out and find the grams of oxygen. Why do we have to do this? Let's go back and look at our original picture. Okay, see this? So we have oxygen being present. That's not part of our hydrocarbon. So if this was CHO, we don't know how, from just looking at the water and the carbon dioxide, how much of the oxygen came from a hydrocarbon here and how much came from this. That's why we need the total amount of stuff that we have, so that we can calculate the grams of carbon and calculate the grams of hydrogen, subtract out your total to find out how many grams of oxygen came from the hydrocarbon and not from the oxygen from outside. Okay, so let's go back to the next page again. So here we go. This is what you have to add to the problem. So take the total mass of this hydrocarbon with oxygen. You're going to find the mass of carbon through factor labeling. You're going to find the mass of hydrogen from factor labeling. And then from there, you can find the mass of oxygen. So you're going to subtract the calculated. So it says upon combustion, here is the whole amount. So in this case, this is 0.8233 grams of the total thing. Contains carbon, hydrogen, and oxygen. Well, it produces 2.445 grams of carbon dioxide. So if you know grams of carbon dioxide, you find grams of carbon. And it takes 0.6003 grams of water. Well, if you know that many grams of water, you can find that many grams of hydrogen. From there, you'll know this amount here, subtracting the mass of oxygen. Find the empirical formula. All right, so what's the first thing I'm going to do? I guess I'll screw it up like this. All right, I need to find the grams of carbon from 2.445 grams of carbon dioxide. And notice how I did this. I kind of split it up. So here I have grams of carbon dioxide, grams periodic table, moles of carbon dioxide, moles of carbon dioxide, moles of carbon, and here I actually wrote down how many moles of carbon. I need this number for later on, but I still need to figure out how many grams of carbon I have so I can subtract it. So then I multiply it by 12.01 and I have it here. If you want to put it all in one factor labeling, then you have to go back and figure out this number again. So I just try to make my life a little bit easier. So if you will, go ahead and do the exact same thing for hydrogen. Will you do that right now? Pause it and figure out the hydrogen. All right, let's see how you did. All right, this is how I did it. 0.6003 divided by 18.1, 1 mole of water, 1 mole. Don't forget, this is the important step here. I'm telling you, from all my years of doing this, people are going to forget this right here. They're going to forget the 2. I've seen it. Don't let that be you, okay? And so then I calculate moles of hydrogen. I still need grams of hydrogen, so I go ahead and do this last step. So now I have grams of carbon and grams of hydrogen. So if I know my total mass is 0.8233, I know the mass of my carbon is 0.668. Let's see if I can't do this with this, 0.668 grams. I know the mass of my hydrogen, woo, that's a good 8, is 0.06, that's a 0, 6, hello, don't do that. Try it one more time, 0.06, that's a 6, 73. Can I then calculate my amount of oxygen if I know my total mass? Yes, I can. Okay, so that was kind of messy. I apologize. But anyway, I can now calculate the mass of my oxygen. So my mass of my hydrocarbon with oxygen, mass of carbon, mass of hydrogen, mass of oxygen. I know the masses. I just calculated these masses. So if I subtract out, I can find the mass of oxygen. Okay, so now what? Well, I have grams, periodic table, I can find moles of oxygen. And that's what this is right here. So I took my 0.088 divided by 16 times, and then I find the moles. And then I just went back and I found my moles from here. I just rewrote this. I told you you're going to need it. Moles of carbon and moles of hydrogen. So now I have my 3 moles divided by the smallest, which is my oxygen. And there's no multiplying. Those are the numbers I got. So it's C10H12O1. Okay? That was a long problem, wasn't it? So what I would like you to do is pause this. It's going to take you a few minutes. All right, so pause this. Please do this on your own. Look at what I did up here. Follow my steps up here, and you do the same thing, please. Okay? So pause this. See how you do. All right, so here I go. I start off with how many grams of carbon, and I start off with 1.6004 grams of carbon dioxide. I go to moles of carbon dioxide, moles of carbon. And I wrote this here because I'm going to use this later. Remember that? But I still want grams. I'm not done yet. I still need grams, so I multiply by 12.01. I get this many grams of carbon. I do the exact same thing with hydrogen. So I go from grams of water to moles of water. Don't forget the 2. For every 1 mole of water, you get 2 moles of hydrogen. And so this is how many moles I have. I convert that to grams. Why do I need the grams? So that I can take the total mass is equal to mass of the carbon, hydrogen, and oxygen. I gave you this number. See, here it is. Mass of carbon, mass of hydrogen. I can calculate the mass of oxygen of 0.2902 grams. Periodic table. So here I'm trying to find the moles, so I get 0.01814 moles of oxygen. So now I rewrite these values right here. Do you see that? I need those moles because what do? Divide by the smallest to get the whole. And that's my actual empirical formula now. So I'm planning on doing problems like these in class next time. Because I know that this is probably some of the hardest work you've probably done so far, or the most complicated anyway. But if you can visualize what you're doing, it'll really, really help you. So yes, be rest assured, we're going to practice these tomorrow. Okay, we'll do some more together. We'll talk about it. So hopefully that helps. Like I always say, don't wait to be great. Bye.